Hello everyone, you're welcome back once again. My name is Victor here. We are still looking at problems that have to do with circle theorems, and in this lesson we are going to be looking at another problem in regards to that. Okay, if you look at this problem without taking our time, you realize that we are expected to calculate the unknown angles in this problem. Okay, and if you are following the classes, you will realize that we've treated several theorems that are guiding us in these solvings. The basic theorem we are going to be using here, of course, this is a tangent. This line is a tangent to this circle. And we have done a theorem on a tangent that says the angle between a tangent and a chord is equal to the angle in the alternate segment. That theorem is important. We are going to be making use of it here and other ones. So please, if you have not looked at the previous classes, you can still check out on those classes so that you can be able to follow what we are doing currently. All right, so look at this problem and where do you think we can start from? Okay, where do you think we can start from? Then I can choose to start from here because, like I keep on telling my students, that in every mathematical problem there must be an access point. You check out to see that access point. Once you see it, from there you can be able to assess the problem and handle it. Okay, I can assess this problem from this place. Reason is that if I say solution, considering triangle ABC, this triangle, you see that B is 90 degrees. Of course, they were able to show that. Even if they didn't show that, one should be able to know that the angle in a semicircle is 90 degrees. I did that proof. Okay. So if you look at it in the previous classes, you'll be able to see the detailed explanation in it. So here, if this angle here is 90 degrees and here 35 degrees, we can say that A, C, B, this one here, plus A, B, C, this one here, then plus B, A, C, this one here is equals to 180 degrees. Why? Sum of angles in a triangle, they add up to 180 degrees. So that's the theorem we are using. You see, we keep on mentioning theorems here. That's the essence of checking back to the classes behind so that you can be able to understand them and then before usage. All right. So if that is the case, that means what we are saying is that ACB, which is this, that 35 degrees plus ABC, which is 90 degrees plus this one, which is M, is equals to 180 degrees. Okay, let me take it up here. It then means what we are saying is that, of course, this and this will give us 125 degrees plus M equals to 180 degrees. Then I can say M is equals to 180 minus 125 degrees. So you realize that M is equals to 180. Of course, 180 minus 120 will give us 60. 60 minus 5 will give us 55 degrees. So M, the angle M here, this is 55 degrees. Okay. Now, do you realize that the next thing I will need to do is either to bring this and this together? Okay, bring this and this together. That is M and Y, angle on a straight line. Okay, so you realize that if I say or alternatively, I can find k. I can find k. So you realize that I can say that k is equals to m. Why should I say so? That k is equals to m. Hmm? Why should I say so? Now, in the last class, the last, yeah, maybe 2 classes behind, I have been able to do a proof that shows that angle between a tangent and a chord is equal to the angle in the alternate segment. You see this tangent touching the circle at point B. You see this chord BC. There's an angle there called K. Now this angle K will be equals to the angle produced. Okay, you see that? Can see that in the alternate. This is the alternate segment to this angle K. Okay, so K should be equals to what? M. By that theorem, you should look at it. All right, so we put it here. We have been able to show that M is 55. That means K is equals to 55 degrees. So we bring in that theorem. Angle between a tangent. We normally use this. Between a tangent and a chord equals angle in alternate segment. I'll be using this abbreviation, so you just take them. Alternate segment. Okay, so K is 55 degrees, backed up by this theorem. Quickly, do you also realize that y? I will do this thing. I told you there are 2 ways to find this y. That you can say y plus m is 180 degrees. That is angle on a straight line by sum of angles on a straight line is 180 degrees. But permit me to say, and by that 180 minus 55, you now find the y. Okay, but permit me to go this way. That y is equals to 85 degrees plus 90 degrees. You'll be asking me how. So this y is equal to these 2 angles. How? I will say external. External, you consider that triangle ABC. External angle of a triangle equals sum of 2 opposite interior. I'm using abbreviation. Opposite interior. Okay? Interior angle. Sum of 2 opposite interior angle. You can see that I've made reference to this several times in the course of our discussion. So I'm trusting God that if you check the previous classes, you understand that that is a theorem of triangle. Okay, external angle of a triangle is it's a very simple thing to show. So you can look at that. All right. So that is what I'm using. So what is y? Y is equals to 125 degrees. Do you realize that if you refuse this way and take it the other way by saying 180 minus m, that will still give you 125. That's 180 minus 55. That will still give you 125 degrees. Okay. Now I am entering into a triangle BAT. BAT. That is this one now. This triangle outside. In triangle BAT, now we know what y is. But we don't know n, we don't know x. You can also see that k plus 90 plus n equals to 180 degrees. How? Sum of angles in a straight line. Okay. So, and we have known k to be 55 degrees plus 90 plus n equals to 180 degrees. This and this will give me 145. You 145? Yeah, 145 degrees. So we have n plus 145 degrees equals to 180 degrees. N is equals to 180 minus 145 degrees. So we have n to be 180 minus 140, remaining 40. 40 minus 5 is 35. So this is 35 degrees. 35, n is 35 degrees. We can now conclude in that triangle by saying but n plus y plus x is equal to 180 degrees. We keep on mentioning theorems. That's how it is. Whenever you come across things like this, just have to be backing whatever you're talking with theorems. So, and those theorems, they have proof. They are not just something we just mentioned. If we took like how many classes behind there to do these proofs before coming up here, so that we don't have to be talking something that is not obtainable somewhere. Okay, so what am I talking here? Sum of angles in a triangle. So that's what makes this. What is n? 85 degree plus y is 125 degrees plus x equals to 180 degrees. So this and this now will give 30 plus 20, 50. 5 plus 5, then making it 60, 160 degrees. 160. So x is equals to 180 minus 160. So what is x? X is equals to 20 degrees. 20 degrees. There's nothing left there. There's nothing left that we can be able to calculate. I think we have been able to show the calculation for all these unknown, angles that they asked us to calculate there. So I am believing that the explanation I gave is good enough to help you to understand, the question. To understand the question. Okay? I'm sure it is of great help to you. Please, if what I have shown you now was of great help to you, like it and then click on the subscription button and then on the notification button, because we are bringing more problems and more questions as well, so stay with us, and as you do that, it's your way of supporting us and of being of an encouragement to us. Thank you so much.